Hello everyone, the topic of this video tutorial is the alert performance functionality in the QSAR Toolbox. Before we start with the example, we need to know what alert performance actually is. Alert performance is calculated as a distribution of chemicals with the same alert group or chemical functionality across potency categories based on the experimental data of the target endpoint. Alert performance can be calculated only if the target endpoint has been defined in advance. It is applicable to endpoints for which the experimental data can be converted into qualitative or potency categories, such as positive versus negative or strong versus weak and non-sensitizer. Alert performance shows the percentage of chemicals with a particular alert group and with positive effect, such as skin sensitization or bacterial mutagenicity test, compared to the total number of chemicals detected with the same type of test data and with that alert. Here, the higher is the value of the alert performance, the more relevant for predicting positive effect the alert is for the target endpoint. Alert performance helps us choose for a read-across purposes the alert with highest positive performance at least in two scenarios. The first scenario covers the case where the target chemical is multifunctional, which means that it has more than one alert in its structure. In this case, it might be difficult to find analogues that simultaneously have the same combination of alert groups as the target chemical. Here, we use the alert performance to select the alert which to be used for collecting analogues. This is the alert with the highest calculated alert performance. The second scenario covers the cases where the target chemical is activated metabolically, producing many metabolites with different alert groups. In this case, we use the alert performance to identify the alert with the highest calculated performance, taking into account the metabolic activation of the selected analogues. To demonstrate the alert performance functionality, let's type the unique identification number of the example chemical. This is a multifunctional target chemical that has more than one protein binding alert in the structure. The target endpoint is skin sensitization, associated with the local lymph node assay. All relevant databases need to be selected. To calculate alert performance, we need to define the primary category. For this purpose, we go to the Category Definition module and select a relevant profiling scheme. This is Protein Binding Alerts for Skin Sensitization by OASIS. 3 protein binding alerts are identified in the target molecule. If we confirm the list of identified alerts, the same combination of protein binding alerts as identified in the target chemical will be searched in the chemicals from the selected databases. However, in most cases with a multifunctional target chemical, no analogues are found. Here, we need to calculate the alert performance. Go to the respective section down and click the Scales button. A new dialog appears with all relevant to the target endpoint scales. A scale is a list of rules that convert the original experimental data, such as EC3 in %, into a potency category. Hovering over a scale in the list, the potency categories appear in the hint message. In the current example, we select the first skin sensitization scale in the list, converting the experimental data into positive and negative potency categories. A section appears below with the so-called aggregation options. By default, the maximal categorical scale is selected, which means that only the maximal experimental data of the chemicals will be used for calculating the alert performance, in case they have multiple experimental data belonging to different potency categories. Confirm selected scale. Now we are back to the previous dialog and click the Calculate button. Calculations appear in a new window organized as a table, where each row corresponds to a single alert or functional group, except for the first row, which shows the calculated performance for the combination of all alerts found. In the present case, alert performance is not calculated for the combination of all alerts found because no chemicals were found that simultaneously contain all alerts identified in the target structure. The target structure contains 3 protein binding alerts simultaneously. The calculated alert performance is provided as a distribution in 2 potency categories, positive and negative, based on the selected scale. The total number of chemicals having that alert which also have experimental data for EC3 is also shown. The alert with the highest performance is activated diaryl esters with 88.89% positive performance based on 8 out of 9 chemicals. Regardless of which alert would be selected for defining the primary group of analogues, it is important to remember that this is not yet a prediction. Profilers are tools for identifying analogues. although some of them show good positive performance with respect to the endpoint they have been developed for. Let's select the alert with the highest alert performance by right-click on the row and select for primary grouping. Analogues are collected from the selected databases. After few more steps we see, there are 9 chemicals with 25 experimental data for EC3, the target endpoint. Now we can predict the EC3 of the target chemical by applying appropriate data gap filling approach using the collected analogues. For this purpose, please watch the respective video tutorial. Congratulations, now you are familiar with the alert performance in Toolbox.